Hey everyone, Joe again, and welcome to lecture 4.3 for module 3 of RAD104. So let's just jump right in. So this is something that I want to share with you, and I find that this is probably the best place of any to throw this information in there. I wanted to share with you some of the dose trends, but first I want to go over real quick the different kinds of radiation that we're exposed to. Now there are two different categories. You have natural exposure, so exposure from the sun, radon, stuff that we ingest, bananas, things like that. Naturally produced radiation that we've always been exposed to. So that's one group. And then you have man-made exposure, so exposure that from procedures or exams or things that we produce that create radiation that affect us or we become exposed to. All right, so let's go over the different kinds of radiation we receive from nature. So if we quickly go down the list, we have internal radiation exposure. That's any type of exposure that's already inside your body. So we have potassium in our bodies, and the potassium can also break down and emit radiation. So we have that in our body. If we eat a banana and we internalize that banana, that too is another potassium-based type of radiation, and that too will produce internal radiation. So not much, 0.4 millisieverts is what we get from internal-based radiation. Terrestrial, from rock, granite. I think I showed you a video once where a guy went up to like a stone monument or a granite monument. He held up a Geiger counter right up to that monument. That is emitting radiation. The ground itself will emit some radiation. So terrestrial radiation, 0.3 millisieverts. Cosmic rays from the sun, from the stars, from outer space. Some radiation does make it through the magnetic field, makes it through the atmosphere and affects us. This becomes an issue if you are at high altitude. You're going to get a little bit more cosmic radiation than others. If you're flying all the time, if you're a flight attendant, you are getting exposed more often than others closer to sea level. So cosmic radiation is another form of natural radiation. Radon is a gas that is emitted from the crust of the Earth. It is very toxic and dangerous and could lead to health problems. So radon, we are exposed to that. Some places are a little bit higher in radon than others. Some houses have to be properly ventilated because of radon, so it's a very dangerous thing, but we get about 2 millisieverts of exposure to radon every year. And then for a total of 3.0 millisieverts, and that is your natural exposure. We all have that. We all get that, with varying degrees of level, but essentially that's what we're getting from nature. Now, man-made radiation is a little bit different because we have some control over that, and not all of us are going to have a CAT scan, nuke med, radiograph, interventional procedure. We're not going to have all of those in 1 year, but if we looked at it as far as a pie chart goes, you can see that CAT scan has quite a bit of radiation to it. It's about 1.5 millisieverts worth the entire pie chart of current radiation exposure. After that, you get nuclear medicine at 0.7. Diagnostic radiography is 0.6, and then interventional is 0.4. Other man-made items, things like smoke detectors, and I can't think of anything else off the top of my head, but there are other man-made items that we have probably in our households that do emit some radiation. Like I said, the most common one that I remember is smoke detectors. So you put all of that together, you have the total exposure for people in the United States of about 3.2 millisieverts per year, and that's what we get. So a couple things to think of, though. One thing to remember is there's really nothing you can do about the natural exposure. That just happens. It's nature. Man-made, however, we do have a little bit of control over. And so if we can minimize the amount of medical imaging procedures we get, then obviously our dose goes down. But I want you to look at the number for medical imaging, which is 3.2 millisieverts. So how does that compare to statistics in the past? It's pretty safe to say that medical imaging radiation is on the rise. So if we looked at those statistics we just looked at in the last slide are from 2008. I'd be curious to see if there's any updated data, but that's the latest information coming out of the book. But back in 1990, if you looked at the medical imaging dose, it was 0.6 millisieverts. It's now 3.2. So that's a huge increase. And if we look at the use of different imaging modalities, radiography has been remaining somewhat steady. It is going up a little bit. Same thing with nuclear medicine. Well, they're all going up. But you can see the jump in computed tomography. That has taken a huge leap forward. And there's different reasons for that. And that has certainly been a big reason why we have such an increase in man-made radiation to the human population. Some studies have shown that the reason for this major increase in medical imaging altogether, but I'm going to say computed tomography for the most part, is that people are using it as defensive medicine. They're using it inappropriately. So to cover their butt, they're using it. They're ordering these tests just to make sure that they're covered legally and that they didn't leave any stone unturned, causing not only a cost as far as financial cost, but also an increase in radiation dose to a patient. So that's one reason. Another thing is that you're going to find that more doctors are starting to own some of these devices. So certainly in radiography, a lot of private physicians are owning their own radiography machines. It's not like you'll find privately used nuclear medicine or interventional, but can some places have a privatized computed tomography department? Possibly. But that is another reason why they're thinking that some imaging modalities are being overly used, is because they own them. And so not only do they get a kickback from insurance companies, but the more that they order, the more money they're going to recoup from that. And so that could be a problem. And then finally, as you have public demand for these exams, I saw, I read in this journal, I saw on the television that if I get this test or if I get that test, I want this test. So public demand has increased as well as medical knowledge online, and so they're requesting their doctors order them one of these exams, and usually the doctors comply. So all of those reasons lead to higher exposure rates to the human being or the human population. And so it's because of this that we want to make sure that we as medical professionals, imaging medical professionals, that we're making sure that images or exams are being ordered for the appropriate reason, that they have to have a documented medical reason for the exam, and we're not doing it just because. And we talked about reasons why people used to have x-rays or chest x-rays, such as just being admitted into the hospital, or maybe it's a pre-employment health screening. All of those reasons are no longer acceptable for an imaging exam. So we have to make sure that we stay on top of that and that we're holding doctors accountable for reasons for exam going forward. The good news as far as diagnostic goes, and actually for CT, I know this as well, that software is also helping reduce the number of repeats. We're able to use the images that we get, and we're also going to be able to track dose, especially since everything is going digital. We're able to find out how much exposure came out of the tube. We can document that. We can keep it with a patient file, and now we can track their dose moving forward, which I think will be helpful as far as trying to save patient dose and just being more aware of how much dose that patient may have already received for that year. All right, guys, and with that, this seemed to be a pretty quick video. Wasn't much to discuss, but I think it's important to know that there is a rise or an increase in all of these medical imaging exams being ordered, and the increase given to the patient population. More radiation is given to people because of man-made medical imaging. So a problem that we need to deal with. So any questions, give me an email. Otherwise, I will see you at the next video.